Assalamu alaikum dear students. Today we will discuss some of the fundamental concepts of thermochemistry, calorimetry, heat of reactions and many more. Now let us start our discussion from thermochemistry and the flow of energy. As you know that the energy is the capability to do work. Energy has no mass or volume. Chemical potential energy is the energy stored in chemicals. So energy is very important as it is the capability to work or supply heat. Now, what is heat? As we know that heat is the form of energy that always flow from warmer object to a cooler object. Heat is represented by a symbol small q. So heat is very important, as you know that when heat absorbs inside the system, then we say the reaction is endothermic reaction, and when heat is evolved from system to surrounding, then we say that the given reaction is exothermic reactions. But first of all, we need to define what is thermochemistry. Thermochemistry is the study of heat changes that occur during a chemical reaction and the physical changes of a state. So, in that branch of physical chemistry, we study the heat changes involved in a chemical reaction. The other thing while discussing the heat changes is the law of conservation of energy, which states that energy is neither created nor destroyed during any physical or any chemical process. So, law of conservation of energy is also considered while we study heat changes in a chemical reaction. So this is the great debate in thermochemistry as exothermic reaction lose heat. However, endothermic reactions absorb heat. Now we will discuss in detail about exothermic and endothermic reactions. In thermochemistry is concerned with the flow of heat between a chemical system and its surrounding. By system mean a reaction under study. So, what is system? A system is a specific part of the universe which is under study or which is under thermodynamic study. However, surrounding is the rest part of the universe which is outside the system, and the thing which separates system with surrounding is the imaginary line which is called boundary, as we discussed earlier. Moreover, the system and the surrounding constitutes the universe. When we add up system and surrounding, then we get what is the all of our universe. Now, there is something more about exothermic and endothermic reaction in thermochemical calculations. What are thermochemical calculations in which heat changes are involved? In thermochemical calculations, the direction of heat flow is given from the point of view of the system. So, what is the system? The system is our chemical reaction which is under study. A process that absorbs heat from the surrounding is called endothermic process. However, the process that loses heat to the surroundings is called exothermic processes. So all these reactions that absorb heat from the surroundings are endothermic, and all those reactions that loses heat to the surroundings are called exothermic processes. So we are discussing in particular the system. By system we mean the reaction which is under study. Units of heat. Normally we use calorie for expressing the heat, but in SI units we use joule as a unit of heat. So this is the general relationship between calorie and joule. We already discussed it before, that is 1 calories equals to 4.184 joule. So this is all about the units of heat. So you must remember heat can be expressed in terms of calories, and heat can also be expressed in terms of kilocalories or joules as well. So energy conversion. Now we practice the units of heat to convert it from calories to joule and from joules to calories. So in the first case we have 444 calories, and we have to convert these calories into joule. Now what we have to do, we have to apply the relationship as we discussed before, that is 1 calories equals to 4.184 joule. So what we have to do, we just multiply this factor, that is 444, with 4.184 joule, and the answers come out to be 1857.7 joule. This calories cancel out with calorie, and we have left with the only unit, that is joule. So this is our answer. In the second case, 850 joules to calories. What we have to do, as you know that joule is the smallest unit and calorie is the bigger unit, so we have to divide 850 with this factor, that is 4.184. Joules cancel out with joule, and we have left with calories. After dividing 850 with 4.184, the answer is 203.2 calories. So we have expressed the heat in terms of joule as well as in terms of calories by using the relationship. So heat capacity, as we already discussed it before, the heat capacity of an object is the amount of heat it takes to change an object temperature by exactly 1 degree Celsius. The greater the mass of an object, the greater the heat capacity. So heat capacity depends on the mass of the object. So you also make a conclusion that heat capacity is directly proportional to the mass of the object. As greater the mass of the object, the greater will be the heat capacity. The heat capacity of an object also depends on its chemical composition, that what is the percentage composition involved in a sample. So this thing is very important when we consider the heat capacity. Now comes to specific heat capacity. The specific heat capacity of a substance is the amount of heat it takes to raise the temperature of 1 gram of a substance by 1 degree Celsius. This is the simple definition of specific heat capacity. Specific heat capacity is represented by a symbol C. The units of specific heat capacities are joule per gram into degree Celsius. Water has higher specific heat capacity than most of the other substances. So you need to remember the definition of specific heat capacity, the symbolic representation of specific heat capacity, and how how specific heat can be expressed into its unit. So these all the points must be remembered. So in this slide here, it is the relationship of heat. Heat equals to mass multiplied by specific heat multiplied by changes in temperature. So small q, heat, equals to m multiplied by c multiplied by delta T, where this small m can be expressed in gram, c is the specific heat, is expressed in joule per gram into degree Celsius, while this change in temperature delta T in this particular case is expressed in degree Celsius. So you must remember here in this relationship of heat, we must express delta T in degree Celsius. So what are the learning outcomes from the above slides? So you must now, and you must answer these questions for the learning outcomes. For one, that is, in what direction does heat flow between two objects? How do endothermic processes differ from exothermic processes? You must know the difference. On what factors does the heat capacity of an object depend? So you must know all the factors. Using calories, calculate how much heat 32.0 gram of water absorbs when it is heated from 25 degrees Celsius to 80 degrees Celsius. How many joules in this? In this problem, we have to calculate the heat. However, the mass is given, that is small m is given, that is 32 gram, and temperature T1 is 25 degrees Celsius. So, however, T2 is 80 degrees Celsius. We can calculate the temperature change by delta T equals to T2 minus T1. So, how can we solve this problem? By applying this relationship. Q equals to small m. What is small m? That is mass of the substance. That is 32 gram is given, and Q equals to m multiplied by C. C is the specific heat. The value of specific heat is constant value, that is 4.184. So you just write up the value of this constant, 4.184 into joule divided by gram into degree Celsius, multiplied by 55 degrees Celsius. This 55 degrees Celsius is delta T, that is 80 minus 25. The answer is 55. Just multiply and divide the values. The answer comes out to be 7363.8 joules. This is the answer in joules. If you wish to express in calories, then how can we convert? By dividing with this factor, that is 4.184 joule. Just divide your answer with this factor 4.184, and the final answer comes out in calories unit, that is 1759.9 calories. Here is another problem for more better understanding of the heat evolved in a system. How many kilojoules of heat are absorbed when 1000 gram of water is heated from 18 degree Celsius to 85 degrees Celsius? Here the mass of water is given, that is 1000 gram. T1 is 18 degrees Celsius, while final temperature T2 is 85 degrees Celsius. How can we find delta T? By the difference of final temperature and initial temperature, 85 minus 18, that is 67 degrees Celsius. Again apply the same formula, that is we have to find the heat in kilojoules. So this small q is heat multiplied by equals to small m is given, that is 1000. What is this value? This is C, m multiplied by C into delta T. This is C. The value of C is a constant quantity. Just put up the value, that is 4.184 joule per gram into degree Celsius, multiplied by 67 degrees C. When you multiply and divide all these values, the answer in joule is 28038 joule. If you wish to convert this joule into kilojoule, as we have to calculate heat in kilojoule, so what we have to do, we just divide our answer with the factor 1000, and your final answer is 280.328 kilojoule. So this is the amount of heat absorbed when 1000 gram of water is heated from 18 degrees Celsius to 85 degrees Celsius. Measuring and expressing enthalpy changes. How can we measure enthalpy changes? As we already discussed, what is enthalpy? Enthalpy is the heat content of a system. We can measure enthalpy with the help of calorimetry. Calorimetry is a technique in which we measure heat changes for any physical or chemical processes. In calorimetry, we use a specific instrument that are calorimeters. Calorimeters are devices used to measure the amount of heat absorbed or released during chemical or physical processes. And in calorimeters we determine the amount of heat, we determine the enthalpy of formation, we can determine the enthalpy of neutralization for any neutralization, for any acid base reaction. So enthalpy is very important in calorimetric experiments. As we know that enthalpy is represented by capital H. So in calorimetric measurements, we can determine the heat changes involved in any physical or chemical processes. So this is a diagram of the instrument, that is calorimeter. In calorimeter, we can determine the heat changes involved in a chemical reaction. This is the reaction compartment over here. We can determine the heat changes with the help of thermometer, and using this setup we can calculate heat, that is small q, that is the heat content of a system, equals to mass of the substance multiplied by specific heat C of the substance multiplied by the change in temperature. So you can determine the heat content in calorimeter by applying this relationship. Heat changes, heat change sign convention. Now what are the heat change sign convention? If you need to focus about the direction of heat flow, when heat flows out of the system, what does it mean? It means that heat is flowing from system to surrounding. Then the sign of delta H must be negative in this case, and the reaction is exothermic. When heat flows into the system, what does it mean? It means heat absorbed in the system. When heat is absorbed in the system, then the sign of delta H, that is heat content, is positive, and the reaction is endothermic. So you must know the sign convention when the heat flows from system to surrounding and from surrounding to system. Thermochemical equation. What are the thermochemical equation? An equation that included the heat change in a heat change is called a thermochemical equation. All those chemical equations that include a heat change. So heat of reaction is the heat change for the equation exactly as written below. So these are the two examples. In the first case, the hydrolysis of calcium oxide gives calcium hydroxide. The heat of reaction for this reaction is minus 65.2 kilojoule. What does it mean? It means that the hydrolysis of calcium oxide is an exothermic process. In that case, the heat is evolved from system to surrounding because the sign is negative over here. This negative sign indicates that this above reaction is an exothermic reaction. In the second case, this is the decomposition of baking soda, in which we got sodium carbonate, water, and carbon dioxide. Heat content, that is delta H, enthalpy for this reaction is plus 129 kilojoule. What does it mean? It means that heat is absorbed by sodium bicarbonate, this much heat, that is plus 129 kilojoule. Heat is absorbed by sodium bicarbonate for the decomposition reaction in order to decompose into sodium carbonate, water, and carbon dioxide. So this reaction is an endothermic reaction because the sign here is positive. Example: when 2 mole of solid magnesium combines with 1 mole of oxygen gas, 2 mole of solid magnesium oxide is formed, and 1204 kilojoule of heat is released. Write the thermochemical equation for this combustion reaction. This is a simple statement. We have to write a thermochemical equation for this reaction. What we have to do, just write and balance this equation. As we have 2 mole of magnesium, write 2 moles of magnesium plus 1 mole of oxygen gives 2 moles of magnesium oxide, and the amount of heat is released. What is the amount of heat? 1204. When the amount of heat is released, then we can write this amount of heat with a negative sign over here, as the reaction is exothermic. So this is a simple reaction that signifies the reaction is exothermic. So whenever in an examination the statement is given, you can write easily a chemical reaction with the help of the given statement. Now we discuss various heat of combustion, heat of formation, and heat of vaporizations. In the preceding section, first of all, we will discuss the heat of combustion. The heat of combustion is the heat of reaction for the complete burning of 1 mole of a substance. Suppose we have 1 mole of a substance, so heat of combustion is the heat of reaction for complete burning of that 1 mole. Next we have molar heat of fusion. What is molar heat of fusion? The heat absorbed by 1 mole of a substance melting from a solid to a liquid at constant temperature. When a substance changes its state from a solid state to a liquid state at constant temperature, then the amount of heat absorbed in this case is molar heat of fusion. In the second case, when heat lost, when 1 mole of a liquid changes to a solid at a constant temperature is the molar heat of solidification. In the second case, when a liquid changes into a solid state at a constant temperature, in this case when heat is lost, then this amount of heat is called molar heat of solidification. As molar heat of fusion is the amount of heat absorbed, so we can write this amount of heat delta H fusion with positive sign, as the amount of heat is absorbed in this case. However, in the second case, the heat is evolved in delta H solidification, so here we can write the negative sign. In the third case, molar heat of vaporization is defined as the heat absorbed by 1 mole of a substance changes from a liquid to vapor. When 1 mole of a substance changes from liquid state to a gaseous state, then the amount of heat absorbed in that case we say that, it is molar heat of vaporization. In the fourth case, in case of molar heat of condensation, the heat released by 1 mole of substance changing from a vapor to a liquid state is called molar heat of condensation. In condensation process, when a vapor converted into a liquid state, and the amount of heat released in this case is called molar heat of condensation. So delta H vaporization, heat of enthalpy of vaporization, is written with a positive sign as the heat is absorbed in this process. However, the enthalpy of condensation is written with a negative sign as the heat is releases in that case. So the last one is the molar heat of solution. The heat change is caused by dissolution of 1 mole of a substance is the molar heat of solution. Suppose we have 1 mole of sodium hydroxide. When we dissolve sodium hydroxide in aqueous solution, sodium hydroxide is converted into its respective ions, that is sodium ion in aqueous solution and hydroxyl ion in aqueous solution, and the amount of heat involved in this case is delta H solution. Heat of solution is minus 445.1 kilojoule. The heat is evolved when 1 mole of any solid dissolve in the aqueous solution into its constituent ions. This is a simple heating curve of water. As you see, on y-axis we have temperature Celsius over here, and on x-axis we have amount of heat added. So in the water, as you know that below 0 is the freezing point, and on 0 degrees Celsius all solid melted. So when we add up heat over here, we get a straight line up to 100, as 100 degrees Celsius is the boiling point of water. So above 100, all the water get transmitted into gaseous phase. Below 100, the water is in the form of liquid state. You see the small L over here, it means from 0 to 100 the water is present in liquid state over here, and below 0 the water is present in solid state over here in ice. So this is a simple heating curve of water, in which water first below 0 it is in solid state, and above 0 it converted from solid to liquid state, and above 100 it converted from liquid to vapor state. So the amount of heat evolved in all these cases are the molar heat of solidification, molar heat of solution, and the molar heat of vaporization in this case. So this is all about of our today's lecture. If you have any questions, you are more than welcome. Thank you for your attention.